Hello and welcome to Chapter 5. I will share my screen and get the show on the road. Okay. Chapter 5 is about surveys and sampling. And so we'll start talking about that using these objectives. We're going to describe the various types of surveys and the concept of response rate. We'll compare and contrast samples and populations, and then we'll describe probability and non-probability sampling methods. The last two will be very likely in the next video. So for the first one, we'll describe various types of surveys and the concept of response rate. So what is survey research? Survey research is just asking questions in an interview or through a questionnaire. So you can do it live or you can do it on paper. Either way is fine. Interviews can be structured, meaning that you have a set group of questions, or it can be unstructured, meaning that your questions change with different interviewers. Focus group is an example of an unstructured set. So you kind of let people talk, you're not too anal about got to have this question, got to have that question answered. That can be administered either face-to-face or over the phone. You can do surveys over the phone as well, or excuse me, interviews over the phone. Questionnaires is when participants answer questions on their own, on paper and pencil or on the web or whatever. Responses can be anonymous there, which is nice because you never have to encounter them and they can feel like they can honestly say what they actually feel. It can also be group administered, in a classroom, let's say. It can be mailed out in the snail mail or web-based email, however you want to do it. Okay, so what is this issue of response rate? The percent of completed surveys that you get out of the number that you attempted to get is called your response rate. And we could calculate that by the number you received versus the total number that you handed out times 100. And if that is low, if that number is low, for example, let's say your response rate is 20%. That means only 1 out of every 5 people answered your questionnaire, which is a real problem. And I'll describe why. If you have very few people answering your questionnaire, you are going to have the problem of you can't tell whether those people are representative of the population. So if you want to do a little activity on this, do pause here and you can see how you can reason out that activity. Okay, objective 2 is to compare and contrast samples and populations. So what is a sample and what is a population? A population is everybody that you want to study. Like, let's say you want to study all new mothers, people who've just had a baby, women who've just had a baby in the last month or so. Well, you can imagine there's new mothers all over the country, there's new mothers all over the world, right? So let's say you just want your population is just new mothers in Missouri, let's say. If you were going to try that to just get all new mothers in Missouri, we would call that a census. You're collecting data from each of these people. It ends up being a huge number, from the United States Census, where they try to collect data from every single person in the United States. It's a huge number. It's very difficult to do. They had a lot of problems this year with the coronavirus and whatnot. So there you see a lot of difficulty. So a lot of times what people do is they choose a small group out of that population. But as you can imagine, the group that you choose should represent the population as a whole. So the sample is a small group of people from which you collect data. The goal is, again, to have a sample which is representative of the population. So it represents the population. It looks like the population. There is an issue that we call margin of error, is the extent to which the sample is not representative of the population. And with margin, we can calculate a margin of error with most surveys. And so you can see in this survey here, where it says source at the bottom of the survey here, it says that it was a poll of 1,001 US adults. There's a margin of error of plus or minus 3.5 percentage points. This is a very large sample, 1,000 adults. And so the margin of error is relatively small, but the smaller your sample, the margin of error is bigger. But what that means is that, say, for example, the people that said they would probably get the coronavirus here, That number 28 actually in the population will range up to 31.5 and down to 24.5, because if we add or subtract 3.5 points, that's our margin of error. So this number is not exactly correct. It's somewhere around there. Okay, objective number 3, to describe probability and non-probability sampling methods. We're going to start with probability samples here. A probability sample is when we know the probability that each person in the population will be chosen, and that probability is not 0. So we know exactly what is the likelihood that anybody in this population of ours will be chosen. We can do that by simple random sampling. And what happens in simple random sampling is you take all the names of everybody in the population and you kind of put them in a hat and you mix it all up and you pull out a sample. So you throw in 5,000 people and you mix it all up, and then you pull out 100 people there. It's generally recognized as the best way to get a representative sample, but a lot of times you don't have this ability, maybe because you don't even have all the names of the people in the population. So you would need that definitely. But if you can get that, what happens is it creates a random sample. So here's your population, and you can see there's a lot of variation in the population. Some of them are green, some of them are gray, pink, orange, etc., and they're different shapes. If you choose a simple random sample where you put them all in the hat and then you pull out, a group of them, you're likely to see the same diversity as long as your sample is big enough. It will represent the population there. So another type of random sample or probability sample is called a stratified random sample. And this is pretty much the same thing as a random sample, except you have several hats. So what you do is you determine some subsamples in a predetermined way before you do the sampling, and then you sample randomly from those subsamples. So you want to make sure, again, that the sample represents the population in certain respects. So let's say you have 2 or more subsamples. So let's say we're going to sample all engineers, okay? And there are very few female engineers. So you're a little afraid of doing a random sample because you may not get any women at all. So what you decide to do instead is randomly sample women engineers out of one hat and then male engineers out of another hat. This is going to ensure that you're going to get some women in your sample. So you may decide to pull 5 women randomly out of the woman's hat, and then the rest of the sample out of the man's hat. And so that would make sure that your sample is representative. Now, what happens is sometimes that's true when you have very small groups. For example, if we were going to measure Hispanic students at Lincoln, we wanted them to be part of our sample, we would probably have to do a stratified random sampling because there are relatively few of that group in our sample. Okay, finally, the last type of random sample is called a cluster sample. And instead of randomly sampling individuals, all you're doing now is randomly sampling clusters of individuals. So if your population is US college professors, and you take, instead of all US college professors, put them all in the hat, you instead take the names of US institutions, for example, University of Missouri, Lincoln University, University of California, et cetera, and you put those institutions in the hat, and then you randomly sample institutions. And then you collect the information from all the professors at that institution. Then you can get this cluster sample. So it's random, but it's not randomly sampling individuals. It's randomly sampling clusters of individuals. So here you can see it in this graphic, that you've thrown in all these clusters, and then you picked the red shirt, the green shirt, and the purple shirt out randomly, and you're going to use all of those as participants in your experiment. Okay, finally, I want to cover non-probability samples. Non-probability samples is when you don't know what the probability of each person in the population will be chosen. So you just simply don't know the probability, or the probability is 0. And so one of those types of samples is called the convenience sample. And that's where you just go out and you just ask people like, would you like to be in my survey? And you just go to places where it's convenient to do so. So for you, a lot of times people take Psych 101 students or students in their classes and ask them to be in a survey. That's a convenience sample. What happens is we're trying to get a population of students, but obviously students in a Psych 101 class are not very representative of all students, right? And so we're not collecting from everywhere. We're just collecting from where it's convenient for us. And so it is hard to know whether the sample is representative, but you do get a lot of data. There can be sampling bias, and that's the sense that you get an unrepresentative sample. If you're trying to represent all students, Psych 101 students are only going to be mainly freshmen. Also, it's going to matter what building you're in, what time of day you do it, even for the class. A 9 o'clock class is not the same group of students as a 5:30 class. It's not going to be necessarily representative of all students. Neither one is. If your subject to your participants are volunteering, the sample is likely to be very biased. If you say, hey, what students want to participate in my study, certain kinds of students are going to participate and others will not participate. So another method of a non-probability sample is to do what's called snowball sampling. And that's when you get one participant and then you ask them to refer an additional participant. So where you have a relatively restricted participant pool, like let's say you wanted to measure people with diabetes, only people with diabetes. If you had one person who participated in your survey who had diabetes, and then you could ask them, hey, could you refer a friend? Do you have another friend with diabetes who could refer here? And again, it's not a very representative sample of people with diabetes. Okay. All right. Well, next time we will go on to objective number 4. Thanks for listening and have a great day.